elasticity of demand. And while we discuss the formula for own price elasticity of demand, we also discuss the concept of point price elasticity of demand. And in case of point price elasticity of demand, we consider a line demand curve. I didn't give the attendance yet, so I'll give midway or at the end of the class, because, many people are, I think only 36 people joined. Maybe some more people will join. So, point price, in case of point price elasticity, we consider a particular point on the demand curve, and we learned that at a particular point on a straight line demand curve, the price elasticity is given by lower part starting from that point divided by upper part. And using this notion of point price elasticity, we found that along a straight line demand curve, point price elasticity varies in between 0 to infinity. So we completed up to this and started to solve a numerical exercise. So are you okay with all this thing?
Yes, ma'am.
Yes, ma'am.
Okay. Now today, first we will start with a numerical exercise. Okay, so would you please write down an exercise? Just a minute. Just a minute. I need to close it once again. Q is equal to A P to the power B. So this is the equation. Now from this, we need to find out own price elasticity of demand. We need to find out E. Now last day, we wrote the formula as actually we started with the concept I'm ignoring the 100 part because already all these things are done. Now, can I write this formula as D log Q? Can we write the thing in this way?
Yes, ma'am.
So everybody is understanding this? dq by q divided by dp by p can also be written as d log q by d log p.
Yes, ma'am.
Okay, so this is another alternative. This formula also you may apply d log q by d log p. Okay, so the equation is equal to q is equal to a p to the power b. You have to find the value of elasticity of demand. Here you can use the formula dq by dp into p by q or dq by q by dp by p. Alternatively, if it is in the product form, many a times we use the idea d log q by d log p. Okay, so can anybody tell me here log q for this equation, what will be the value? Equation is q is equal to a p to the power b. This is the equation. So if this is the equation, what will be the value of log q? Anyone?
Log A plus B log P.
Very good.
B log P.
Okay, and easily you will be able to calculate what is the value?
B.
B.
Yes.
Okay. And if I use, the minus sign, so from the very beginning, so it will be minus B. Okay. Or if I consider the absolute value of the price elasticity of demand, we are getting the value to be B. Okay. So which is a constant. So for this kind of curve or equation, Q is equal to AP to the power B, we are getting okay, so we can easily derive, the
Ma'am,
value of the elasticity if the equation is in product form using the logarithmic version of the entire thing.
ma'am,
Using logarithmic version of the equation. Yes. And
ma'am,
every time I ask if you have any question. So why you are disturbing?
oh, okay, ma'am.
Tell me your question.
Ma'am, one thing, ma'am, but dq by q by dp by b, ma'am, equal to the next part. Ma'am, that part actually I couldn't understand, ma'am.
Which part?
Ma'am,
dq
this part, ma'am, minus,
divided by dp by p.
yeah, ma'am, equal to the d of log a by d of log p, that part, ma'am.
D of log Q, not A.
Oh, yes, ma'am, log q, sorry, ma'am, actually, I misread it, ma'am. This part, ma'am,
D
yeah.
log Q by D log P. You did it at your +2 level calculus. What is the derivative of log Q?
Ma'am, 1 by q,
1 by Q.
yes, ma'am. Oh, acha, acha, from that part you did it. Okay, ma'am, thank you, ma'am, got it.
Okay, we can take differentiation of D of log Q. This is equivalent to 1 by Q dq. Okay. So now I hope you got it,
Yes,
or
ma'am, yes, ma'am, I got it, ma'am.
so we are applying simple calculus here. Anybody else, any question regarding this? Or you could derive it using the standard formula. You can use always the minus sign, it doesn't matter. So while I am doing this kind of numerical problem, actually I'm considering the modulus value. And in this way too, if you consider the standard way, that is, if you derive dq by dp, then the value will be a b p to the power b minus 1 multiplied by p into q. And then if I replace p by a p to the power b, in that case, q is already a p to the power b, so the value will be b. Clear? So for this kind of demand curve, we get constant elasticity of demand. Therefore, this demand curve is called constant elasticity demand function. Constant elasticity demand function. Now, please write down this assignment. When the price elasticity of demand is equal to unity along the entire demand curve. If I consider a linear demand curve, we understood only at the middlemost point the value is equal to 1, elasticity is equal to 1. Now I am talking about a particular type of demand curve when price elasticity of demand is equal to unity along the entire demand curve, whatever be the point along the demand curve. If you measure elasticity, the value is equal to 1. This kind of demand curve is called unitary elastic demand curve. Okay, unitary elastic. So this is a special variant of constant elasticity demand function. So here, U1 is also a constant. However, this is a special variety in the class of constant elasticity of demand function, where price elasticity of demand remains unity along the entire demand curve. So the assignment is, when the price elasticity of demand is equal to unity along the entire demand curve, show that the demand curve becomes a rectangular hyperbola. The demand curve becomes a rectangular hyperbola. Now anyone, please tell me what is the shape of a rectangular hyperbola? You did it in your mathematics at class 2 level. Person is no more there.
Ma'am, is the downward decreasing and exponential type.
Downward decreasing and exponential type. Anyone else? You know,
It's convex to the origin.
it's convex to the origin. Would anyone will like to add anything?
It's asymptotic to axes.
Very good. It is asymptotic to axes as well. So all points adding together, this is a rectangular hyperbola. It is convex with respect to the origin, negatively sloped or downward sloping curve, and the line, becomes very close to both the axes. However, the line does not intersect the axis. In other words, the line comes very close asymptotically to both the axes. Asymptotically, it is merging with both the axes. So if there is a downward sloping convex curve which asymptotically merges with both the axes, in that case, the curve is called rectangular hyperbola. Okay. So the question is, or the assignment is, when price elasticity of demand is equal to unity, we will have a demand curve which is a rectangular hyperbola. Now, anyone, if the demand curve or any line is a rectangular hyperbola, can you tell me what will be the shape of the equation? What will be the functional form of the equation? What will be the function?
Ma'am, PQ will be a constant.
PQ will be a constant. Okay. Is equal to BC. So if we get this kind of thing, in that case, very good, we will have the equation to the rectangular hyperbola. Okay, so you have to start with the elasticity formula. You have to set the value to be equal to 1, and you need to check whether from this equation you can have a line like this. Okay, so you have to start with the elasticity formula. And considering the absolute value of the elasticity altogether. So this is d log q by d log p. We have to set this to be equal to 1. And from there, now, anyone please tell me what will be the next step? what I'll write in the next step.
Ma'am, we will integrate both the sides.
We will integrate both the sides. Very good. Integrating both sides. Would you please continue what we will get integrating both sides?
Log Q will be equal to log P. And won't that be -1 that elasticity
I'm
does?
considering the modulus value. So, we can proceed like this and later we can adjust the minus sign as well. No problem.
Then log Q will be log P plus C.
I didn't get you. Would you be a bit clear?
Then by integrating d log Q equals to integrating d log P, we will get log Q equals to log P plus C.
Log Q
Yes.
Everybody is getting this? Integrating both sides, we are getting log Q is equal to log P plus B. B, you can consider any value of the constant, okay? Here, I gave this kind of equation, P into Q is equal to B, therefore, I'm writing the constant to be equal to B. Actually, we are getting a constant, any constant. Okay, so after this, what I'll do,
Log of Q by P equals to B.
log of Q by P is equal to B. Log of Q by P, or what I'll do,
मैम बीटा के log भी नहीं निकल
Log Q minus log P is equals to B.
so this is the equation we are getting.
Yes, ma'am.
And from here, next step,
And then Q by P will be a constant because B is a constant. Then e to the power B will be a constant as well.
so what I'll write, please tell me. Anyone, please tell me.
Log Q by P is equal to V.
After that, am I right? Other steps okay?
Then we consider when Q by P is equals to e to the power B.
This, so are we getting the equation of the rectangular hyperbola? Is there some mistake? Is there any problem? So think about this. You have to get this equation of the rectangular hyperbola. Whenever the price elasticity of demand is equal to 1 along the demand curve, the line will be a rectangular hyperbola. You are very close to the idea, however, still we didn't get it. So think about this.
Ma'am, if we take B as log B,
If we take B as log B, yes, So think about this, we need to complete this assignment.
Ma'am,
You
if
have
we take the
look at
elasticity as
this.
-1,
I want to get, we want to get the standard formula. We don't want to put the value to be equal to 1. We are starting with this and we want to find out the standard formula for a rectangular hyperbola. Okay. Almost very close to this thing. Just think about this. Think about this, We will come back to this. Okay, so here more about the constant elasticity of demand curves. The value can be minus 0.5, minus 1, minus 2, and up to minus infinity as well. So what is the concept? This dark blue is the standard equation for rectangular hyperbola. Then it can be like this, or very light shaded curve. Okay. And if I consider this line, then the elasticity is becoming minus infinity. Or if I consider, this is very steep, in that case, elasticity will be equal to 0. Okay. So this is the equation to the rectangular hyperbola. Q by P is equal to A, or Q is equal to BP. This will be the equation. So this is the set of equations for rectangular hyperbola. So now if you write down this equation, I hope the problem will be solved. Instead of capital A, please write down B. So these constant elasticity demand curves Q is equal to AP vary with respect to their elasticities. Curves with negative finite elasticities are convex to the origin. The vertical constant elasticity demand curve is perfectly inelastic. This is the extreme, and horizontal demand curve is perfectly elastic. So this is the bunch of rectangular or constant elasticity of demand curves, and it can take different values. Somebody told, we may consider the value to be this, value to be that, so always we will consider the standard formula. We can generate all possible values of the elasticities. Okay, so this is the general case. Okay, so all these curves are indicating rectangular hyperbola. However, we are working with the equation where elasticity value is equal to 1. Elasticity value is equal to 1. Okay, in the earlier problem. Okay, if somebody comes, and I need to, make the student joining the
Yes,
class.
ma'am. Sumit is telling that he can't join.
Yeah, however, now he is not here. So that's the problem. 2 times coming, Okay, so this is the general case. So
Ma'am,
it is there. Please complete the assignment. Okay, complete the assignment regarding the rectangular hyperbola. Yes, I'll take your questions. Let me proceed. From the idea of elasticity of demand, okay, we are proceeding further. We are trying to rewrite the equation using other variants of microeconomics as well. So that now the question is, how do total consumer expenditure change when price of a good changes? How does total consumer expenditure change when the price of a good changes? Concerned commodity is X. Okay. And we are now talking about expenditure. Expenditure. Capital E indicates expenditure. Okay. So capital E is based on the concept of quantity into price. Quantity into price. Okay. Expenditure is quantity into price. Is there anyone waiting?
No, ma'am.
Expenditure is P into Q, because when I have a demand for say 10 units and price of the commodity is say 8 units, my expenditure will be 80 rupees. 8 rupee is the unit price and I want to buy 10 units. So my total expenditure will be 80 rupees. So expenditure is nothing but price into quantity. So what I am doing, I am considering D of capital E. In the suffix, I have written XP. That is, I am defining this E to indicate the expenditure on X, where quantity demanded is given by small x amount and unit price of the commodity is given by P. So D capital E suffix XP by DP. So change in expenditure due to change in price. Now for the expenditure part, now I am writing P into Q, P into Q. This Q is nothing but quantity demanded, and we know this Q is a function of price. So I have D, P into Q, where Q is a function of price. And in the denominator, I have DP. So it is in U into V form. P into Q, where Q is a function of P, that is in U into V form. So if I take derivative first with respect to P, I'm getting the value Q only, Q or Q suffix D, I'm getting Q, plus P, this P remaining constant, now I'm taking derivative with respect to P. So if I take derivative of the expenditure with respect to P, we get Q plus P dQ dP. Is it okay?
Ma'am,
Yes.
Yes.
what is the
Yes.
part is DB, capital D and then P?
Which part you want to know? This capital E?
No, ma'am. After that, yes, ma'am. This
P
capital D.
into Q.
No, ma'am. After that,
D.
D.
Quantity demanded. Suffix D. Q suffix D.
Okay. And then
Okay.
after that, P.
Q is a function of P. Quantity demanded is a function of P. Am I right? Quantity demanded is a function of P. Is it visible? If I keep in this format, is it visible? Okay, so D, P into Q, basically Q suffix D. I'm writing here. I'm considering expenditure function. This I'm putting here to indicate this is the expenditure function. Okay, if the commodity is X, small x will be the quantity, P is the unit price, is equal to P into this. This is the expression. Is it clear now?
Yes, ma'am. But why we write that P, ma'am? Ma'am, quantity demanded.
Quantity demanded, yes. This is in the suffix to indicate it is not the quantity supplied. I'm talking about quantity demanded to indicate that.
No, ma'am. Actually, ma'am, he's asking why did you write the capital P in the bracket? Actually, quantity demanded is a function of price.
Function of
That's
P.
why ma'am has written.
Yeah, I told you, this is the thing. Quantity demanded is a function of P.
Okay.
Okay, price we are getting from the market. This is the price of the commodity. However, my quantity demanded depends on a particular price of the commodity. If price is 8 rupee, I'll demand something. If price is 100 rupees, my demand will be something depending my income, etc. Okay, so quantity demanded is a function of P. If I do not write P, in that case, there may be some mistake while you are taking the derivative. So explicitly, I am writing as a function of P. Many a times we considered this quantity demanded function. In Walrasian Marshallian stability context, we defined quantity demanded, quantity supplied as function of P. So many a times already we did this thing, okay? So this is not new to all of you, that you did in some earlier cases. In fact, all earlier cases, isn't it? QD is equal to, just a minute. QD is equal to, we did the thing in this way. So everybody is fine now with the notations, etc. Everybody is understanding this is in U into V form. While we will take the derivative with respect to P, yes or no? Still there is some doubt.
Yes, ma'am.
Okay, so if I take the derivative of P into Q, where Q is a function of P, first I am keeping Q as a function of P constant and taking the derivative with respect to P. So I am getting back only Q. Then I am keeping P as a constant and taking derivative with respect to this part. So P into dQ by dP. Then I am taking Q common. So I am getting from this equation, if I take Q common, 1 plus P by Q are we getting this? If I take Q common,
Yes, ma'am.
yes, no, understandable?
Yes,
Everybody is
ma'am.
understanding?
Yes, ma'am.
And this P by Q dQ by dP, this idea is related to elasticity of demand. Am I right? Can I replace this by elasticity?
Yes, ma'am.
Yes, ma'am.
Okay. So this is equal to, if I consider the elasticity value is equal to minus dQ by dP, we can write this as in this format. So you use the notation small e in place of elasticity and simply you write down the thing in this way. Considering E to be minus dQ by dP into P by Q, I'm writing the equation dE by dP, D of expenditure by dP. Change in expenditure due to change in price is given by Q into 1 minus E. Okay, and if I explicitly write E, in that case, if I consider this minus sign, minus are basically absolute value of elasticity that we are indicating. So if I do some fine tuning, I can write the equation as Q into 1 minus mod E. Now, if mod E, this value is greater than 1. If mod E is greater than 1, what will be the sign of this entire thing? If mod E is greater than 1, what will be the sign of this Q into 1 minus E?
Negative.
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 Negative. If absolute value of the elasticity is greater than 1, the dE by dP, that is becoming negative. That means expenditure decreases when price increases. Expenditure decreases when price increases. So other thing remaining constant, if price increases, consumers' expenditure on particular commodity decreases. Alternatively, if the price elasticity of demand is less than 1, modulus value of the elasticity is less than 1. Here we considered elastic demand. Here we are considering inelastic demand. So if the demand is inelastic, in other words, mod E is less than 1, total expenditure increases when price increases. So if price elasticity of demand is less than 1, in other words, if the commodities are inelastic, in that commodity demand is inelastic, in that case, as price increases, expenditure increases. On the other hand, if commodities are or demand is price elastic, in that case, expenditure decreases when price increases. Okay. So last day we talked about elastic demand, inelastic demand, and we related the concept with quantity demanded, price, etc. However, now from the elasticity concept, we are coming to the expenditure concept and trying to relate both the concepts. So if a commodity demand is inelastic in nature, in that case, even if price rises, we have to buy this commodity. Demand is inelastic. If price changes, demand does not respond to this. So if this kind of commodity is there, in that case, as price increases, expenditure increases. On the other hand, if the commodity demand is quite elastic, in that case, for a small change in price, demand will fall and expenditure will fall. So this is the idea. There is an example of cell phone nowadays. People need to do business in the morning. So this elasticity, here capital E underscore under subscript P, that is elasticity. It is equivalent to small e. So when elasticity is low, so cell phone companies increase the rate while customers will spend more. But E is high in the evening since people do not have to talk. So cell phone companies lower the rate to encourage customer expenditure. Okay, so many a times this happen. We call it peak load pricing. Peak load pricing. In peak hours, rate will be something, that is charge will be something, or price will be something, and during the time when the demand will be not that much, in that case, I can reduce the unit price so that people get some incentive to buy that particular service or commodity more. So when demand will be quite less, then I am reducing the price, selling price, and when demand will be quite high, I am increasing the selling price. This is the idea of peak load pricing. Whenever there is a peak of use, in that case, I'll increase the charge, selling price. Whenever there is, almost no demand, in that case, I'll reduce my selling price to encourage the customers more to spend on this particular commodity or service. So this is the idea, However, at this moment, the idea of peak lot price is not that important to you, because when we will talk about the markets, etc., definitely the idea of peak lot pricing will come. However, here this part should be very clear to you. If the demand is inelastic for certain commodity, in that case, even if price rises, demand will, or expenditure will rise. And if the commodity demand is elastic, in that case, due to increase in price, there will be a fall in expenditure. So at this moment, this part is more important, relating the idea of expenditure with price elasticity of demand. Okay, any question? Any question in this derivation, in this idea, in these statements?
Ma'am.
Any question? Yes.
And the difference is in what, ma'am? Please make one more time.
Just would you please repeat?
And the differentiation part, ma'am.
Differentiation part. You into V differentiation, you know?
Yes, ma'am.
Okay, so in case if I get U into V format, how we will take the derivative? First, I'll keep V constant and take the derivative with respect to U, plus I'll keep V constant. Sorry, I'll keep U constant and take the derivative with respect to V.
Yes,
So
ma'am.
it is, you know, sorry, where E is equal to U into V. Okay, and both U and V are functions of P. So what is the standard formula? Keeping V constant plus. Okay, both U and V are functions of P. So this is the standard formula. Are you familiar with the standard formula?
Yes, ma'am.
Okay. So in that case here, what are the things we have? P into Q. So first I am keeping Q constant, taking the derivative with respect to P. If I take the derivative with respect to P, what will be the value?
The value will be, ma'am, Q, but why don't we write the QDP here
You
as
can,
it is written
this
earlier?
is only the matter of notation, okay? You know, this is a major course, okay? This is like this, you know, this is equivalent to this.
Okay, ma'am.
You can use all the notations if you like, no problem.
Okay, ma'am, I got it, ma'am.
Okay,
That's where I was confused.
okay, I got it now. Okay, so these are the matters of notation. Here explicitly I have written everything so that you don't forget the fact that Q is a function of P. Don't consider Q as a constant. That was the idea, okay? Therefore, I explicitly wrote Q is a function of P. Otherwise, you will write, you know, dQ by dP equal to 0. If you consider Q as a constant, in that case, if you take the derivative with respect to P, that will be equal to 0, which is absolutely wrong. And for that matter, I wrote the whole notation. However, when I completed the job, you can write the whole notation if you like. No problem. I just avoided to keep it simple. That's all. Here it is very, very important to understand Q is not a constant. Q is a function of P. Okay. Anyone? Again, if anyone have any question, anyone have any question, you know? Because many a times we think that you are understanding the matter. However, you know, in the beginning, all of these issues may come. So no problem. So would you please ask me if you have any question further in this part? So it's clear? Yes, for everybody? So nobody is understanding. You are understanding the matter?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay,
Yes,
so now
ma'am.
it's clear, I hope. So can I proceed to the next part?
Yes, ma'am.
Yes, ma'am.
Okay, okay. So using the notion of elasticity of demand, now we will go for another format, which is again a very useful concept. So now we will consider the price elasticity of demand from the producer's view. When we consider when we relate the price elasticity of demand with the concept of expenditure, we are looking at the problem from the view of the consumer. Okay, so how does total consumer expenditure change when the price of a good changes? So I looked at the problem, from the consumer's viewpoint. Now I'll use the same concept, that is the concept of price elasticity of demand. However, now we will like to derive a relationship where we are looking at the price elasticity of demand from the producer's viewpoint, from the seller's viewpoint, Okay. Now, before going to this relation, okay, let me first tell you about several things. Seller's perspective. The same thing which we considered in context of expenditure. In context of consumers, okay, quantity demanded. Okay. The same thing, if I look from the seller's perspective, it will appear as the revenue, price into quantity sold. That is giving the sellers the revenue component. Okay. And if QD is equal to QS, expenditure, the whole expenditure the consumers are making, that is coming as revenue to the sellers. Okay, so these two things will be equivalent at equilibrium when QD is equal to QS. Okay, so expenditure is P into Q, that is the consumer's perspective. P into Q is again coming in the analysis of the suppliers or the sellers. However, this appears as the revenue of the sellers. Okay, so this we consider as total revenue. We use the notation TR. TR is equal to P into Q. Okay. Now, if I want to find out average revenue, what I'll do?
And TR by Q.
Yes. PQ. Okay. Now this P equation P is equal to A minus BQ. This is the standard format of the linear demand equation. Okay, so average revenue is equal to P is nothing but the demand curve. That is, it is indicating the line P is equal to A minus BQ. So from the producer's perspective, if I look at the demand curve, this demand curve is nothing but the average revenue curve. This is average revenue curve. Okay, or it is this line. P is equal to A minus BQ. So from the seller's perspective, we can consider P into Q as total revenue. In that case, average revenue is becoming PQ by Q, which is P. Okay. And this P is indicating to the demand curve, P is equal to A minus BQ. Now there is another concept called marginal revenue, which is MR. MR is the marginal revenue. It is change in total revenue due to change in quantity sold by 1 unit. Marginal revenue is change in total revenue due to change in quantity sold by 1 unit. Okay. Margin in context of economics indicates change. Marginal utility, that means change in utility. Marginal revenue, that means change in revenue. Marginal cost, that means change in cost, etc. So margin or marginal in context of economics indicates change. Marginal revenue is change in total revenue due to change in quantity sold by 1 unit. Okay, so you know how we can write the formula for marginal revenue? If it is change in total revenue due to change in Q, it's different.
Ma'am, could you repeat it once more?
I am telling that if this is the definition of marginal revenue, change in total revenue due to change in quantity by 1 unit, can we write marginal revenue in this way, DTR by DQ? Is it okay?
Yes, ma'am.
Yes, ma'am.
So we write MR as DTR by DQ. Okay. So now dq of tr I have to write. So again that u into v format is coming.
Yes, ma'am.
Everybody? Okay. So here the derivative is with respect to q. Here the derivative is with respect to q. Remember that thing. So first q remaining constant. If I take the derivative with respect to p, what I'll write? Anyone?
And Q dp dq.
Q into dp by dq.
Q is definitely a function of p. I may not explicitly write this because we are understanding. Am I right? Did you tell this thing? Q
Yes, ma'am.
dq
Yes.
plus what I'll write?
P.
Everybody is okay with this?
Yes, ma'am.
Now I'll take p common. One plus this I'm taking p common. So p into 1 plus q by p dp by dq.
Yes, ma'am.
Yes, ma'am.
So are you getting something close to elasticity of demand?
Yes, ma'am.
That is 1 by E. Like
That
C
is
by
1 by E. Very good. That is 1 by E. This time we are getting 1 upon E because E is dq by dp into q by p. So we are getting 1 upon E. So I am writing here. Okay. So what I am getting is equal to
Ma'am, 1 plus only.
look what I am writing. Okay. So are you getting the minus sign?
Yes, ma'am.
Okay. So here also, if I look at the same thing from the seller's perspective, that is, I have the idea of price elasticity of demand. Now with this idea, how I'll make some idea about how much the quantity I'll be able to sell. Now this is the idea for the sellers. For the buyers, it was the thing, elasticity of demand is like this. So what I'll do if price increases? What I'll do if price falls? Now for the sellers, elasticity is given like this. So if this is the elasticity, how much I'll sell? Like this kind of thing. Now before closing this part, I'll rewrite the equation in, as finally okay, so this equal to, MR is equal to P into 1 minus 1 by mod E. Now, left hand side is MR. So MR is equal to, now I told you, P is equivalent to AR. Here, we got this. So we can replace P by AR, average revenue, and we can rewrite the equation with this form. MR is equal to AR into 1 minus 1 upon E. Got it?
Yes, ma'am.
So this is the equation. MR is equal to AR into 1 minus 1 by E. This is the idea. Okay, so already all these things are done. So is this clear to all of you? This derivation?
Yes, ma'am.
Okay. Now, if mod E, so we have this equation, you know. This is the context, okay? Now, if price elasticity of demand is tending towards infinity, what will happen?
Ma'am, 1 by E will take
Marginal
0.
revenue is equals to
1 by E will tend towards 0.
Yes.
yes,
Ma'am, MR
ma'am.
equal to AR.
MR is equal to AR. And in that case, what will happen? MR is tending towards
Infinity.
Infinite.
MR is tending towards infinity. Yes. 1 minus 1 by 0, you know, so it is infinity kind of thing. So P is a fixed amount. So this entire thing will move towards, you know, infinity. So these are the extremes. And then you can consider so if E is greater than 1, if E is greater than 1, what is happening? If price is demand elastic, if this denominator is greater than 1, if denominator is greater than 1, what will be the sign of this entire thing?
Positive.
Positive.
Okay, suppose 5. Greater than 1, that is 5. 1 minus 1 by 5. This is the idea. So MR is, and price is always positive. So MR is positive. Okay, so if the demand is elastic, in that case, dTR by dQ, that is positive. If output increases, output sold increases, in that case, total revenue will also increase. The sign will be positive. Alternatively, if E is less than 1, suppose it is 1 by 5.
Then
In
MR
that
is
case, it is
negative.
Negative.
Yes.
negative. So, as the selling amount is increasing, change in revenue, DTR by DQ, that is falling. DTR by DQ, that is falling as the producer is selling more and more. The marginal revenue, that is change in total revenue due to change in Q, that is decreasing. So all these aspects we can do, we can check, once we get the relation, MR is equal to AR into 1 minus 1 by E. Okay, later in context of production, we can use this concept to measure the market power of a particular firm. Okay, so this is the relation between the price elasticity of demand and the marginal revenue. You can work with this for different values. You can check how the total revenue will change when output is increasing or when QS is increasing, etc. Next, we are moving to the idea of cross price elasticity of demand. Cross price elasticity of demand. Cross price elasticity measures the relative responsiveness of quantity demanded to change in price of a related commodity, other determinants of demand remaining constant. Relative responsiveness of quantity demanded to change in price of a related commodity. Okay, so here I'll work with X and Y. X is the concerned commodity, Y is the other commodity, other related commodity. So price of X remaining constant, if price of Y increases or price of Y decreases, what will be the impact on demand for X? What will be the impact on demand for X? That we will be able to guess if we look at the values of cross price elasticity of demand. However, remember that other determinants of demand should remain constant. So cross price elasticity, for measuring cross price elasticity, I'm using the notation EXY. It is percentage change in quantity demanded for X due to percentage change in price of Y. So it is del X by X into 100 divided by del PY by PY, P suffix Y, remember, into 100. Alternatively, it is del X by del PY into PY by X. Y is in suffix of X. Del X by del P of Y into PY by X, price of Y by X. So this is the definition of cross price elasticity of demand. It can be positive, it can be negative, it can be equal to 0. If it is equal to 0, in that case, the commodities are unrelated to each other. If cross price elasticity EXY is equal to 0, in that case, the commodities are not related to each other. Okay, so demand for a cup of morning tea is not related conceptually to the demand for shoe. Okay, demand for shoe may be related to demand for dress. However, demand for tea cannot be related to the demand for shoe. So it's not that in reality, all the commodities will be somehow related. It is not so. Some of the commodities are related, some of the commodities are unrelated. If the commodities are unrelated, cross price elasticity is equal to 0. Okay, now the value can be positive as well. Now, if EXY greater than 0, what does it mean? As price of Y is increasing, demand for X is increasing because the sign is positive. So both the numerator and the denominator will move to the same direction. price of Y increases leads to demand for X increases. Okay. So what is happening? Price of Y is increasing. That is reducing the demand for Y, and that in turn is increasing the demand for X, price of X remaining constant. This indicates X and Y are
Substitutes.
substitutes. Substitutes. Okay. I have made some. Is it okay? Next. Because the sign is negative. Okay. So price of Y is increasing, demand for X is falling. If denominator increases, numerator should fall. If denominator falls, numerator should increase. So this will be the relation when EXY is negative. Now EXY is negative, that indicates price of Y is increasing. That in turn is reducing the demand for Y. And this reduction in demand for Y in turn is reducing the demand for X. So what will be the interrelation between X and Y?
They are complements.
X and Y are complementary to each other. X and Y are complementary to each other, like, pen and ink, hardware and software, bread and butter, milk and sugar, etc. Complementary to each other. Okay. So EXY greater than 0 indicates X and Y are substitutes to each other. On the other hand, EXY less than 0, that indicates the commodities are complementary to each other. And the value is equal to 0 indicates the commodities are unrelated to each other. Got it? Any question?
No, ma'am.
Finally, income elasticity of demand. Income elasticity of demand. Relative responsiveness of quantity demanded to change in income, other determinants of demand remaining constant. So percentage change in quantity demanded for X due to percentage change in income of the individual. Income I am denoting by capital M. So percentage change in quantity demanded for X due to percentage change in income, which is given by M. So del X by X into 100 divided by del M by M into 100. That is equal to del X by del M into M by X. Del X by del M into M by X. Are you getting the definition? Other things remaining constant, income elasticity of demand indicates responsiveness of the demand of the concerned commodity due to change in income of the individual. So I hope everybody is getting this.
Yes, ma'am.
Okay. Now, there can be different possible values of income elasticity of demand. Okay. It can be greater than 1, it can be equal to 1, it can be less than 1. If I Okay. Sorry. So, all possibilities are there. Among these, EXM is equal to 0. That means the commodity is totally not responsive to the change in income. The demand is not responding when there is any change in income. Okay, so demand is fixed. Income inelastic. Demand is fixed at a particular level with respect to income. Okay, it will not change when income will change. So demand is income inelastic. Okay, now if EXM is equal to 1, EXM is equal to 1, in that case percentage change in quantity demanded is exactly equal to percentage change in income. Percentage change in quantity demanded is exactly equal to percentage change in income. Whereas when it is greater than 1, percentage change in quantity demanded is greater than percentage change in income. So actually, if E is greater than 1, we call the commodities are conspicuous commodity with respect to their consumption or luxury goods. If EXM is greater than 1, that indicates you are spending more compared to the rate at which your income is changing. Okay, so income is changing by say 2 units. However, your expenditure is changing by 100 units. This is the idea, greater than 1. So if this happens, percentage change in demand is greater than that of percentage change in income, and in that case we consider the commodities as the luxury goods. Alternatively, if E is equal to 1, that is coming in the category of the normal good. Normal good. Okay. EXM less than 0, sorry, EXM less than 1. Now, if it is in between 0 to 1, in that case also we will consider the commodities as the normal one. Because there is some increase in demand, however, that is less than that of increase in income. So, for these two, or in other words, okay. However, in this less than 1 category, if I get the value this, in that case, as income increases, demand falls, or as income falls, demand increases. So these commodities are called inferior commodities. Inferior commodities. Just a minute. Yes. হ্যাঁ বলুন আচ্ছা আপনি একটু অপেক্ষা করুন আমি আসবো হ্যাঁ আচ্ছা Okay, so is it clear to you?
Yes, ma'am.
Yes, ma'am.
So E greater than 1, when responsiveness is higher with respect to change in income, luxury goods, normal goods, inferior commodities. And this is income in elastic demand. Okay, so this is all for today. And next day we will consider, some exercises relating the notions of price elasticity of demand, and you will do more in your mathematical economics classes. Okay, so several exercises, several numerical things we generally discuss in context of mathematical economics too. Okay, so let's stop here. And first let me check.